Hello and welcome to the second bonus lesson of the drum game video set. In this video, or I guess over the next several videos, we are going to add to our game the ability to use a Rock Band 2 style drum kit. Up to now, we've been using the original Rock Band 1 style kit for any sort of drum style input. I mean, technically that's the same as actually using a game controller, but Rock Band 2's drum kit is a little bit different.
That's right. In addition to the 4 drum pads, you also have up to 3 additional cymbals. Now, the interesting thing about the Rock Band 2 kit is it was built to be backwards compatible with Rock Band 1. The idea was that you could use your Rock Band 2 kit on the Rock Band 1 game, and the game wouldn't know any different. Now, they had to do a few things with the button encoding to accommodate this. The idea is that, of course, Rock Band 1 had no concept of cymbals versus drums, so everything had to be color-based. You had your A, B, and X, Y buttons that were used for the drum input, and those rules of a specific color being a specific drum still had to be followed with the Rock Band 2 controller. Now, around this requirement that the colors still link directly to drums, we now have the addition of cymbals that are also colored. So now we're in a scenario where we're sharing a color, but have to somehow be able to tell the difference between a cymbal and a drum.
Right.
And this results in a form of button encoding where multiple button presses allow you to decode exactly what drum was hit.
Okay.
So through this video series, what we're going to be doing is putting together a few classes that are going to handle both decoding the raw input from the Rock Band 2 controller and setting up that input as a standard input class inside of the game.
Now, if for some reason you want to follow along with exactly the same equipment we're using, what drum kit are we using? It's not just the out-of-the-box Rock Band 2 kit, is it?
Right, we've actually got the Ion Drum Rocker kit,
Okay.
which is kind of a third-party deluxe version of the drum setup. But the idea is the decoding for all of the main drums should be exactly the same. Depending on things I've read on the net, there's a possibility of an extra port. I don't remember if it was a kick port, but one extra port on the official kit that the Ion doesn't have. But aside from that, there should be little to no difference between the actual encoding, since Rock Band 2 is going to be Rock Band 2. So we're just worried about getting the main drums separated from the cymbals so that we can gain access to each individual drum and cymbal separately to give ourselves more tracks we can use.
Cool.
Now, specifically in this lesson, what we want to accomplish is just a way to look at the raw input coming from the Rock Band 2 kit. Because, of course, we know that we're going to have some kind of button combination coming in to tell us what drum and what cymbal is hit and how to separate them, but we need to see what we're working with.
So the symbols themselves aren't really going to be considered to be separate buttons. It's not like A, B, X, Y, and then we're using, I don't know, shoulder buttons or something else for the symbols. They're going to be, what, combinations?
Exactly, and looking at the both the Rock Band 2 kits and the Ion Drum Rocker, the cymbals themselves can be color-coded as well. You have the little color ring that you put attached to it on the drum rocker. So the idea is that the cymbals themselves carry a color property. The problem is that color property links directly to the button that matches that color. So your green cymbal is always going to link up to the A button. And that means that without decoding further than just the colored button, they would do the same thing. So hitting the green drum and the green cymbal would apparently result in the same input.
But that's not desirable.
Exactly. Here we want to maximize the tracks we can use, so we want to separate everything out to individual drums.
I gotcha.
So what we're going to do is we're going to put up a simple scenario where we will dump the incoming input from the Rock Band 2 kit out to the log inside of our game. But we're going to do this in such a way that any simultaneous button presses that have occurred in the same game update will all be drawn on one line. This will make it easier to tell simultaneous button presses apart from button presses that happened later in time. But the idea is that being able to review the raw input will give us an idea of what types of modifiers or the buttons may work as. So, to get started, let's make a few modifications to the way our log is working to make it easier to see everything that we need to look at. To begin with, I'm going to open up the log class, and then I'm going to close everything else except the log class. Just clear out our workspace so we can focus on the drum input. Now, with the log itself, the first thing we'll do is we'll actually bring it back to being enabled. We had disabled it earlier when working on the final version of the skin. We're going to turn this back on by setting the enabled value to true to bring our log back. Now, the other thing we're going to do is we're going to adjust the log so that it occupies the entire screen. The reason we're going to do this is I'm actually going to increase the font size that the log is using just to make it easier to read the inputs after this video has been compressed to its final size. That's the size that you'll be viewing it at.
Mm-hmm.
So, in order to change that, we'll bring up our Game1 class and scroll down to Load Content. Inside of Load Content, we're setting our log's height. Currently, we're setting it to 185. We'll comment that out for the time being and change it to global state.fixedDrawingHeight. So we'll make the log take up the entire screen. And second, we'll change the font that we're using in our call to log.initialize from font small to font large.
Okay.
Just to make it a lot easier to read what's going on. Now, one final thing I'm going to do, since we're going to be jamming on all the different buttons, and currently, as far as the game's concerned, the drum rocker is just a standard gamepad. I mean, it still has to follow the same rules that any other 360 gamepad would abide by. And at the moment, if you hit the back button, the game exits. We want to be able to test the B or red button without the game exiting. So the easiest way we can do that is to go up here inside of input pressed, and temporarily we'll pull out all of the code that would normally pass the inputs along to screens and possibly exit if the correct button was detected.
Okay.
So temporarily pulling that out, and that way we can play with whatever we need to work with. Now, in order for the Ion to show up, or the Rock Band 2 kit to show up, we currently have it connected to port 2, as indicated by the LEDs on the front of the controller. Now, that means in order to see the input in the game, we are going to have to bind some buttons to those inputs. Actually, let me think about that for a second. Upon further review, we'll put that off till later.
Okay.
So we can look at the input here in just a minute.
All right.
All right. So if we run the game briefly, we should be able to see that we have the game still visible, but behind the transparent log, we can also see that the log line describing our sound engine is indeed a lot larger.
Yeah, it is.
All right. So now we've got a viewable area that'll make it a lot easier to work with data, and now it's time to start reading out some of that data. What we're going to do to get access to the raw inputs is we'll actually use the current gamepad input class, since that's what's right now going to be assigned to the Ion drum rocker. So what we'll do is we'll load up gamepad input, then we'll scroll down to our update method, and before any type of, after all the input has been handled, we want to gain raw access to whatever was in this pad state, regardless of which controller it was. So we should be getting updates for all 4 controllers based on the way our gamepad system is set up. So what we're going to do is, once all of the standard input has been handled, we'll simply look at the pad state, look at all of the values inside of that gamepad state instance, and see what buttons were pressed. If any buttons were pressed simultaneously in one update, we'll make sure that those all get put into a single line. Now, since we are going to run into a scenario where we'll need to assemble lots of small strings repeatedly, we're going to use a string builder class to do this, just to make it a little bit more efficient and faster. So what we'll do is we'll have a string builder, and we'll just call this SB, and set that to be a new instance of string builder. Now, with our new string builder class, we need to start looking for various button presses. Now, in order to make it easy to loop over all of the available buttons, we're going to use one of the methods found in the enumeration type itself. If we look into enum, we can see that we have a method called getValues. And getValues will return an array containing all the values in an enumeration of a specific type. This will be useful to us, since that way we can make a loop that will loop over all available gamepad buttons, instead of having to hard-code all of the buttons that exist. Now, getValues is going to need the type of the enumeration we wish to loop over, or rather retrieve all the items from. So we're going to use type of, and then specify buttons. Now, this is going to return an array. We'll need to cast this over in order to store it. As a matter of fact, we're going to be storing it inside of a buttons array. Now, of course, before that can be stored, we do need to cast 2 buttons. So, after running this line, we should have all of the buttons stored in the variable we haven't yet named. Let's just call this buttons. So we should have all the available buttons stored into buttons, and this is useful because we could begin a for loop and then loop for 0 until the number of buttons dot length. That way we'll loop through all the buttons, button by button. Now, as we're looking at them, what we want to do is see if the specific button is pressed, and if it is pressed, then show it out to the screen. So we'll say if buttons sub I, actually buttons I needs to be checked. Again, we're going to be using, we can use the current pad state. The idea is that we're looking at this guy's pad state that we were retrieving before looking at the different button events. We want to use that same pad state to check. So we'll actually be doing pad state dot is button down, and then pass in the specific button. So if the button in question is down, then we will append its name to our string builder. So I can do sb.append. And looking at where did we define string builder, because it's not wanting to give us the name. Ah, I see. When we declared this field, it was not yet static. We are inside of a static method. Therefore, the field must also be static. So now I can take string builder.append and feed in buttons sub I dot toString. Then to make it easier to read, we'll separate the actual pieces of text by a pipe character. So we will run a second append where we'll drop in a single character as a pipe symbol. Alright, once we have assembled all of the buttons using our string builder, we want to do a check. So now outside of the for loop, we want to show whatever's in the string builder, but only if there was something written to the string builder. And we can check that by looking at the string builder's length. And if that is greater than 0, then the string builder contains some data. So string builder.length is greater than 0, then we will do a log.writeLine. So we can pass out string builder sb.toString. Alright, looking at everything here, we should, if we run now, see input. So let's jump in and build the game. Ah, very interesting. One thing to note, I'll just go ahead and show this right off the bat. The reason we're seeing left stick is there is a special indicator value that you get back from the Rock Band 2 controller. The left stick button is used to signal whether or not the kick pedal is plugged in.
Oh.
What that means is, as long as the kick pedal is plugged in, the left stick is continuously down.
Gotcha.
So what has happened is, one, we're seeing the left stick over and over again, but you see all the pipe symbols being added? What that is the fact that we're not clearing out the string builder. Meaning we assign some buttons to string builder, we show it to the screen, later in time we end up at the top of this function again as update gets called again, and we continue to append. We never clear out the string builder.
Gotcha.
So let's see, right before the for loop, let's take string builder and set its length to 0 to effectively clear out any information that's inside of it. So now if we run, we see the following.
Okay.
And you saw just, I don't know how fast the captured frame rate is going to pick this up, but you could actually see for a second the scrolling of all these inputs. So basically at the game's input rate, we're seeing left stick over and over again. Also, there's an extra pipe symbol getting tacked onto the end. Just to clean that up a little bit, what we could do is right before we draw the string builder text, we could actually take the string builder's length and decrement it by 1, and that will chop off the last character.
Gotcha.
So that way it's a little bit cleaner. We're seeing just left stick. Now, looking at the various drums, let's try hitting a few things. If we hit the A button, actually looking at the input here, let me first do a check here. Actually, just to show this, let me unplug the drum input entirely and rerun the game. So now we see that the left stick is still showing up. Let me check this. All right, after a quick off-camera break, we have discovered that something within the driver got foobarred because we needed to unplug and replug the Rock Band 2 kit in order to get it to behave correctly. Something about that left stick input somehow got jammed at the, I'm assuming, driver level. Because at the moment, we have the kick pedal unplugged. If we run the game, we see no input streaming across the screen. If we plug in the kick pedal input, then we see left stick streaming across the screen. If we unplug it again and then hit something like the A button, now we can see a few lines of A button input.
Okay.
Then
So if the same thing happens on their end, they should just try unplugging the kit and plugging it back in and go from there.
Exactly. What also might be affecting it is this is actually the first time we've had the Rock Band 2 kit hooked up to the recording station.
Yeah.
So maybe it was just something about the driver getting used to the input.
Okay.
But yes,
Sort of initialization thing.
So with that out of the way now, we do have the ability to see all of the various inputs, meaning if we hit the A button, B button, or any of the buttons on the actual controller module to the drum kit, we can see that we can watch all the inputs stream up the screen. Now naturally it's going to continue to move across the screen as long as we hold the button down, simply because we're running this draw call every single update.
Right.
So that means as long as the button's held down, we'll see it stream to the screen. The key is that we can see multiple button presses. For example, if I hit the A and the B buttons, you can see we have A, pipe symbol B. So we can tell when we're hitting multiple buttons.
Nice.
So that'll become useful here in just a minute. Also, we do want to be able to test the kick pedal, but we don't want our screen cluttered by this left stick pressed call.
Okay.
So what we're going to do is we're going to set up our display loop to ignore that. So as soon as we get into this for loop, we're going to do a check and say that if buttons sub I is equal to buttons.left stick, then we'll simply continue to the next loop iteration, thereby skipping any output.
Right.
So now if we run the game, we do indeed have the kick pedal plugged in, as seen by being able to hit the kick pedal button, and that's giving us the left shoulder input.
Gotcha. Very cool.
So with that now, we should be ready to begin taking a look at exactly what the various buttons do. First thing to note is the fact that the kick pedal on the Rock Band 2 kit is exactly the same as on the Rock Band 1, and we can actually prove that by jumping into our current config.xml file and scrolling down to our game input, where we are currently binding the gamepad input of left shoulder to note 6, or the kick track. So just pointing that out, that nothing special has to be done with the kick input. Now, what we're interested in is the way all of the different pads and symbols work. So let's bring our test game back up, and let's begin playing around with some of the pads themselves. Because in the past we were looking at individual button presses for drums. Let's see what happens when we hit the red drum pad on the Rock Band 2 kit. You see we actually got a whole bunch of interesting stuff. We got a single hit of the left thumbstick being pointed in the right direction, followed by a few hits of the B button. So B was what we were looking for actually. The red drum should be the B button. So we see the B button a few times. But in addition to the B button, we also see that the right stick was pressed, and then the left thumbstick continued to be moved in the right direction.
Wow.
So quite a few things coming back. Now if we go through all of the different drums, so if we hit the yellow drum, we get Y button, we get right stick again, and we get a different direction for the left thumbstick. If we hit the blue drum and then the green drum, see we get the X and the A inputs, different directions on different thumbsticks. But one thing stays common throughout all of this. We're always seeing the right stick being pressed whenever we see any of these inputs. Now just a quick description of what that thumbstick is doing. The Rock Band 2 controller has the ability to detect pressure sensitivity in addition to the hit itself, and that's where we're actually getting the reading for exactly how strong the drum was hit. We need an analog input to read that, so we're using the actual amount that the thumbsticks were moved to tell how hard the drum was hit.
Gotcha.
Now, for our purposes in the drum game, we don't need pressure sensitivity because the rest of the game does nothing with any type of pressure-sensitive information.
Sure.
So for our own purposes, we don't need to worry about the thumbstick directions. As a matter of fact, just to make it easier to read the output, what we're going to do in this debug output is filter out anything that has the word thumbstick in it, just to make this easier to read. So in order to do that, what we'll do is we'll say that if the current button is pressed and the name of the current button doesn't have the word thumbstick in it. So we would do that by saying if buttons sub I dot toString dot contains the word thumbstick, and capitalization is important here. We have to match exactly how thumbstick is showing up in the output. And we want the inverse of this condition. So basically, if the button converted to string does not contain the word thumbstick, go ahead and log the output. Otherwise, filter it out entirely. So now, if we jump into the game and hit a drum, now we're just looking at right stick and B.
Okay.
And these are things that are going to be relevant to us as we begin decoding things. So again, going from red drum, yellow drum, blue drum, green drum, we see we have B, then Y, then A, then X, then A. And we also have this right stick that stays along with everything. Let's try some of the symbols now. If we hit the green symbol, we get right shoulder in A. So green drum, then green symbol. So both of those are the A button, but you see we're getting a different button indicating which was which. So what's happening is right stick is noting the fact that a drum was hit.
Mm-hmm.
Right shoulder is noting the fact that a symbol was hit. And then the button itself describes which symbol or which drum was being hit. So let's look at some of the other symbols. Let's take a look at the yellow symbol. So at this point we would expect right shoulder and Y. But if we hit the yellow symbol, we get a little bit more information.
Nice.
We do get right shoulder and we do get Y, but we also get D-pad up. So now things are getting more complicated. Also, if we swap over to the blue symbol, and I'll just note this briefly, we don't actually have a third symbol hooked up to our kit here, so I'm simply swapping the input from the green symbol to the blue symbol back and forth.
Yeah, the kit was expensive enough. We didn't buy the extra symbol.
And with the module the way set up the way it is, it's very easy to swap inputs. So with the blue symbol connected, if we hit blue symbol, now we get yet another input. We get D-pad down, and then right shoulder and X. So looking at these, we do still have some buttons in common. We do have right shoulder across the board for A, Y, and X. And then the A, Y, or X button denote the color, so A would be green, Y would be yellow, and X would be blue. But then this third input is interesting. We get an D-pad up input if we're hitting the yellow symbol, a D-pad down input if we're hitting the blue symbol, and no input in that slot, if you'll call it that, for the green symbol.
Interesting.
So what this input is actually pointing to is it's acting like a flag, saying that the blue symbol is pressed, the yellow symbol is pressed, and in its absence, if a symbol is pressed, then we're meant to assume that that was a green symbol.
Okay.
So what appears to be happening is the designers of the scheme were trying to conserve buttons as much as possible. So therefore, there wasn't an input used on green symbol hit. They were just assuming that if you're seeing symbol, and we are because we're seeing right shoulder, then we're meant to assume that if we're not told yellow or blue,
that it must be green.
then we must assume green.
Yeah.
So we'll need to be taking that into account when we begin decoding symbols. Now the reason we have this symbol was yellow or symbol was blue value was in case we got a specific combination. So far we've been hitting single drums, but we do in fact have two drumsticks, and that means we can hit up to two drums simultaneously. So we need to be able to handle stuff like what would happen if someone were to hit the yellow symbol and the blue drum at the same time. So let's see if we can hit these at the same time to get some test data. So yeah, looking at these few lines, you'll also note a little bit of what I'm calling noise pop in. I hit the two drums at the same time when we got a single symbol and then everything combined.
Right.
This is probably just owing to the fact that I was, at least a little bit off hitting the two
We weren't
drums.
exactly simultaneous, but nobody would expect it to be.
But there, for part of the duration of the hit, we did get two samples of everything stuck together. So now we've got a lot of input on one line. We've got D-pad up, right stick, right shoulder, X and Y. So we can see that from X and Y, a blue and a yellow hit occurred.
Gotcha.
From right stick and right shoulder, we can see that both a symbol and a drum occurred. Now, at the moment, that's ambiguous between, which was the symbol and which was the drum.
Right.
Well, now we're carrying this flag of D-pad up, meaning that, then that was hard-coded to yellow symbol was hit. So if we know that both were hit and the symbol was yellow, then we know that, the blue hit must have been a drum.
Nice.
So these are the kinds of scenarios that we're going to need to be decoding. So,
Interesting exercise in logical patterns.
one last thing I do want to note is that when we go to decode the symbols, of course, that D-pad up and D-pad down is going to become integral to finding which symbol was hit. One last thing is the fact that if you hit a symbol separately, you do get the symbol was hit flag, D-pad up or D-pad down.
Mm-hmm.
If you manage to hit two symbols at exactly the same time,
Yeah, I was wondering about this.
then you actually drop the flag.
Wow.
Because, I mean, and it kind of makes sense. You can't, if you hit two symbols, you can't have the symbol was blue flag.
Right.
Because there was also a yellow symbol hit. So in order to counter that, they take the flag out altogether.
Gotcha.
So basically, if you see that we were hitting a symbol, now granted, we can still decode this. Because we can see that we're hitting a symbol, right shoulder, we're not hitting a drum, there's no right stick hit, and we see the colors that are being hit. So then just looking at that directly, that has to be two symbols.
Right.
But we do have to take that into account. If we get too comfy with our symbol was blue and symbol was yellow values for directly decoding everything, we still have to counter what happens when we hit two symbols at exactly the same time. Alright, with all of that now, I believe we have enough data to begin working on some actual code. So with that, I'm actually going to take out our testing scenario, put the log and everything back the way it was.
Okay.
As you're working through these videos, you may want to keep the log at least partially visible, just as a reference, to be able to go back and see exactly what it is you're hitting. Now, for the moment, since in addition to this I have my own cheat sheet on exactly how everything works, I am going to pull the log out and put everything back to the way it was, just to keep the game in a playable state.
Okay.
That way, at the end of the lesson, we don't have to worry about tying up any loose ends. So that means, very briefly, we're going to jump into the game class. We happen to be looking at the input press method, so I'm going to uncomment the code that handles input or exits the game. So we'll bring our input handling back. Then I'm going to go down to the log. We'll change our log size back to 185 for our log height, and change the log font back to font small. So with this, let's also take out the debug input from gamepad input. And for the time being, I'm just going to comment it out just in case it would become useful at a later time. But once everything is up and running, then we would be free to pull it out entirely. But for the time being, I'm just going to comment all of this out. So down to the end of our... Actually, let me pull that back one. Down to the end of our if statement.
Okay.
And one quick look over the game just to make sure that everything is back to the way it should be. And I'm actually going to pull our log visibility back out as well. So that means one jump here over to log, enabled to false. And we do still have input. We can still jump into the various aspects of the game. We can still exit the game. So everything as far as the game is concerned is back to normal. So with that, that's going to wrap up this video. And in the next video, we'll begin taking a look at some actual decoding code.
Cool.